Hello guys, in these videos I will uh, introduce how to sketch or how to build a 3D models for the wave cover. This type of wave cover is telescoped. This is a 4 sectors telescoped wave cover, shield cover, and here is the model of a milling machine or router machine. There are two wave cover at the front and the back, and here I cut the section. And the model is here. It's around 1.2 meter in length for the machine length, and I think it's 700 or 600 millimeter in width. And I will go into the detail how to build this movable wave cover. You can see here the front one is extended while the rear one is in retracted manner, and I will move this table back and forth and to see how this wave cover shrink or retracted. So I first open this. This, you can say this is a lead screw, or I'm now using a linear actuator, and here there's datum pin here, and I change this retracted position by its stroke. The stroke is 328, so I now extend this one into full length at the stroke, and then we drain the model, and it go to the most extended position, and then I go back to the 3D model of the machine, and I now go to the regeneration of the whole model and see how the wave cover change in length started. Now you can see it moved. All the things are moved because the movable part, the related movable parts are connected, are related with the previous linear actuators datum. And here I cut the sections, and you can see the constructions of the wave cover. There is the scissor here, and how let me show the model here. There is two scissors. I just build the one side only. Actually, here is another scissor here. And during the retraction or extension, this scissor also will be collapsed. Now, this model, I will show how to build this. Firstly, I have the original solid model. This cannot be called a skeleton, just a simple solid model. And there is a sketch here. It tells the total length and the height. Most important is it was divided. This curve is divided equally into 4 sections. And I use the datum line to here. There is datum line here. I divide this into 4 equal spaced points here. You can see there are 0.25, 0.5, 0.75. This is important when this sketch length change, when I need to adjust this length of the model a little bit. These points are also stretched or compressed in equal spaces, so it is easy for me to adjust the model. And here, after drawing the sketch, I do the solid model for each sector by using bend this into this position and offset a little bit and do the same again. Not a complex, not a complicated 3D model. Then go back to the assembly model. After building the solid model, I need to subdivide it into 3 sectors. I import the solid model for each part and then subdivide it. So of course they are related, so whenever the original solid model was modified, was adjusted in length, then this sector also change in shape. I don't need to do each one, do adjustment on each one. And this model is not very complicated, and using the datum point in the previous model here, and then build a cutting plane to slide out 4 sections. And this assembly model is a little bit complicated, and firstly I need to draw a line here. And you can see there are three points here corresponds they are correspond to 4 sector, so they are also equally divided into same length, and this line is in this length, so I just need to build 3 sector here and 3 points, and then assemble each sectors related with this point. Of course, I need to build a datum pen to assemble it. Anyway, each sector is assembled into this assembly related with these points, because this curve will change in length during the contractions or extension stages, so they are assembled in a related position. This 4 sector was assembled first, then this is the longest curve on the top. Anyway, and then I need to assemble the scissor in this position, so I need to sketch a line here as well. And also build the points there. You can see there the 3 points are also equally spaced there. These points will be used for the location of these small pieces, the pivot pieces here, as well. When this length change in this curve change in length, then these points also will be moved, and these pivot pieces will also change in position. Of course, I need to build the axis there for the assembly of these pivot pieces. Afterwards, I draw a individual small curve there here. 1, 2, 3, 4 pieces. Actually 3 pieces is enough. And then draw the middle point here, on each individual small curve. This middle point is used for the location of these pivot points here. First, I assemble this small pivot piece here first, and then I will draw this scissor line, this curve, and in building this line, this curve, I constrain the ends of the curve on the points there, here. So whenever these points change in position, this scissor curve will be changed as well. Of course, I need to, for the assembly position, I need to build the datum plane along these scissor short lines. Then I will make these steel pieces pass there, here, and two hole or two axes on these holes. And this length will be, between these holes will be a fixed value. This is 118. Because I now have the assembly datum for this metal strip, the datum position is 2 axes here, and also some datum plan here. Then I will assemble these metal pieces, each metal pieces here. All these metal pieces are assembled. Then this model is finished. This model was assembled into the big model here, and another trick is here. After assembly this model, this ray cover here, I will do some trick here. Remember, in the ray cover assembly model, firstly I have sketched a line here. This is the very first step to build the ray cover assembly model. This is important curve, and then I do the equally spaced point here. This line is now adjusted in the whole assembly model, and I go back to here, this line, and I modify it. It's better to flip the section. Okay. It's not this. So this is the image of the curve here. sorry, I forgot to mention one thing. During the assembly of this ray cover subassembly into the model, I assembled this surface with the surface of the T-slot stable here, while the front end is not assembled, and then assemble the center position and the bottom position. Then I go back to modify this curve length, this length with this value. You can see one end of this length is constrained to the table, this surface. End of this curve is constrained to this surface. Another end of this curve, for easy understanding, I constrain this into this surface. This surface is fixed on the machine, so the end of the ray cover is fixed on this end, while the opposite end of the ray cover is fixed on the movable table here. You can see here. So whenever this linear actuator support change, this table, T-slot table also change in position and bring this line to a shorter length or to a longer length. This end is fixed here, 134 millimeter, and later on I will delete this dimension and use a fixed datum plane of the big model datum plane here for this dimension. This is same. I can use both dimension, either here or use here. This point is fixed. So the trick is here, and everything is done, and I do it again for the, and also I just mention a little bit more. The pivot boxes was located here on first section here. The second pivot box is located on the second pieces here, as well for the third and fourth, while this pivot point is connected with for the two metal strip and is feed on the ray cover. Actually, I need to assemble a small pivot passes here as well, but I just skip it now, and you can see the contracted stage here, and take care not to collide with each other in the contracted manner. Here there is small gap. And I now do the movement again. At this position, now I subtracted to a midpoint. So it's now in the middle position, and I go back to the whole model, and I just need to click the rejoin button, then the whole thing's move, and here is in the table is in middle position. Each ray-char file assembly also change instantly. To a middle length. Thank you for your watching.